Okay, so we got to deal with that root. So typically we're going to let x be 6 sine theta is the method we use, and we'll see why that works out when we draw our triangle. If we want, we can solve for sine theta. In order to draw our triangle, we can get dx, because we're going to need to sub that out as well when we go to theta. And then we can draw our triangle. Let's see. So this is theta, right? Then opposite over hypotenuse is going to be x over 6. And of course, if we solve for this side, we get, and this is why this works, we get 36 minus x squared. Sorry, having trouble with my pen, my stylus. We get 36 minus x squared square root of that, right? If you do your Pythagorean theorem. And that's no coincidence, that's the same statement that we have in our integral. All right, so if I sub out, let's see what happens. That's going to be square root 36 minus 6 sine theta quantity squared. Divided by x. And then dx is 6 cosine theta. Okay, it's pretty standard so far. And then at this point, I guess anything can happen, right? What kind of integral are we going to be dealing with? Well, right now this should be, if you factor out the 36, 1 minus sine squared theta is cosine squared theta. So that would give you 36 cosine squared theta, square root that guy, and that's 6 cosine theta. 6 sine theta, and another 6 cosine theta here. And then what am I left with after the trig substitution? I end up with a 6 cosine squared over sine squared. I'm sorry, cosine squared over sine. Okay, and that could look familiar. It could be something we did with our trig integrals. We have a bunch of methods for this. What I would try is change everything to sine. I think that might work, right? So that's 1 minus sine squared over sine. So far, so good. And then I can break this up, and that gives me 6. 1 over sine is the cosecant, and then sine squared over sine is the sine. Okay, and this is the part that we don't, that's a minus sign. We don't see this guy very much, the cosecant of theta integral, right? In fact, I don't even know, it's something you could do in Calc 1, but it's one of those things, at least when I teach Calc 1, I say, okay, we know the derivatives of all 6 trig functions. Those are easy to establish. But we don't know the antiderivatives of all 6 trig functions. We know the antiderivative of the sine and the cosine function, right? And then we know all the antiderivatives of the derivatives, as we know the antiderivative of secant squared. But if I ask you for the antiderivative of secant, you might not know that. And this is what we rely on our tables for. So this one, you just have to look it up. This guy right here. Okay, and I think it should be the natural log of cosecant plus cotangent. You might want to double check on that. So that would be maybe the unique part of that is this one integral is not something that is very nice. That should be I believe it's the negative, I should look this up. Check my work here. I think it's cosecant plus cotangent. Okay, and then of course the antiderivative of sine, we do know that one. Well, that's the cosine. And we have to decide, is the plus or minus there? The derivative of the cosine is negative sign, so that should be a plus. Okay. And then the last step, again, we're back to the pretty standard method. I think the integral of the cosecant was something you don't see very often. But from here, then we go back to the triangle, right? And this is where you get these really interesting answers. We had down here 36 minus x squared. There's theta, and that was x, and that was 6. Okay, so we can replace each of these statements with its algebraic equivalent, right? So this would be the standard part. You do this on most of these problems. That is, fill in what the ratio should be here. For example, the cosine, that would be an easy one. The cosine would be this divided by this, right? Adjacent over hypotenuse. That's the square root of 36 minus x squared all over 6, and so on. And the cosecant, right, that's the reciprocal of the sine, so that should be 6 over x. And then the cotangent would be the reciprocal of the tangent. The tangent is this divided by this. So you could have this guy, the original function we integrated happens to be the cotangent of the angle theta from our trig substitution, I think. Okay, sorry how that's so messy. I don't know what's going on with my pen. It's very sensitive. But that's the idea. And then I'm missing my plus C, and we could maybe clean that one up a little bit. But I hope that helps.